Welcome back everybody, Professor Blankenship here with another stats video. Now we're going to be taking a look at hypothesis testing, but doing a one-tailed test. So you're using a one-tailed test when you want to determine if the mean is less than an amount or greater than an amount. So this would be like if you don't really worry about whether the amount of money you make is greater than a certain amount. You only care if it's less than. Or you're wanting to make sure that the time to completion is less than a certain number, but you don't care exactly how much. You just want to make sure it's done faster than a certain time. So let's take a look at a few examples using one-tailed testing. So here we have a couple examples of some z-stats. Now, when you're dealing with one-tailed testing, it can be a little bit confusing when you're determining p. We have our different regions of rejection here with our different nulls and alternative hypothesis. Now, when you're looking at the null and alternative hypothesis, the alternative hypothesis always points towards the region of rejection. So, in an upper tail region of rejection, the mu is going to be greater than whatever it is. So it's always going to point, like a little arrow, point towards where the region of rejection is. So in a lower region of rejection, the mu, it's going to show less than on the alternative. So then based off of the z-stat, we can tell which lower or upper region and how much is going to be in the region of rejection and in the region of non-rejection. So now when you're looking at regions of rejection in one tail, a couple things to remember. If you have a lower region of rejection, the p-value corresponds to the z-stat on your z-table. So when you would look this up on your z-table, it would correspond to whatever value this shows, both whether it's positive or negative. Now, in an upper tail value, your p-value corresponds to the inverse or the complement of your z-stat. So let's go through these. So at a z-stat of positive 2, what is our p-value in an upper region of rejection? So with 2, because it's upper, we look up the inverse, so we're going to be looking up negative 2. So negative 2 on our z-table corresponds to 0.0228. So now we're going to look up negative 1.38 on our lower. So we know that lower is going to correspond to negative 1.38, so we're going to look up negative 1.38. So this is a p-value of 0.0838. So now we have a positive 1.38 with a lower tail rejection. So 1.38 in a lower tail, we're going to look up 1.38. So this gives us a p-value of 0.9162. Now, we're again looking at an upper with a negative 2 z-stat. So because it's upper, we're going to want to look up the inverse. So we're going to look up 2 on our z-table. So 2 on the z-table is 0.9772. You want to remember, when it's upper region of rejection, you take the inverse of the z-stat. When it's lower region of rejection, you look up and use the corresponding z-stat. So now let's determine whether we reject or fail to reject. So depending on the level of significance will determine whether you reject or fail to reject. So let's say we're looking at 95%, which gives us a level of significance of 0.05. Because we're using a one-tailed test, we don't have to split this between two tails. The whole entire level of significance is going to be in one tail. So now we have to determine whether P is less than the level of significance, because when P is low, HO must go. With a p-value of 0.0228 and a level of significance of 0.05, we reject HO because P is less than the level of significance. Because P is low, HO must go. So now let's take a look at the z-stat of negative 1.38 in a lower region of rejection. So this gives us a p-value of 0.0838. So with a 0.05 level of significance, we do not reject HO because the p-value is greater than the level of significance. Now looking at positive 1.38 for our z-stat, which gave us a p-value of 0.9162, in a lower tail, because we have a p-value of 0.9162, which is greater than our level of significance of 0.05, we do not reject HO. So now for our last one, we're again looking at an upper tail region of rejection with a p-value of 0.9772 and a level of significance of 0.05. We do not reject HO because our p-value is greater than the level of significance, and you reject only if p is less than the level of significance, because if p is low, HO must go. So here you can see the different bell curves and how the regions of rejection play based off of whether it's an upper or lower region of rejection, and the z-stat for each different hypothesis test. So now let's take a look at an example problem. All right, now let's take a look at how to calculate a one-tailed test using your t-table. So at 10 degrees of freedom and a 0.01 level of significance, we need to determine our critical value of t. So because we're looking at a one-tailed test, we look up 0.01. We don't have to split it between two tails. So on our t-table, we look up the upper tail value of 0.01 at 10 degrees of freedom, which gives us a critical value of 2.7638. So now let's say we have a t-stat of 2.39. So for our HO and our H1, because we're looking at an upper tail, it means our HO is going to be less than or equal to, and our H1 is going to be greater than, because your alternative hypothesis points towards your region of rejection. So when we're looking at a t-stat of 2.39 to determine whether it is within the region of rejection, we have to look at, is 2.39 less than or equal to our critical value of t of 2.7638, or is it greater than our critical value of t? So because our t-stat is less than our critical value of t, we do not reject HO at a 0.01 level of significance. So now let's take a look at another example. So say we have a t-stat of negative 1.15, 20 degrees of freedom, and we're looking at a level of significance of 0.01. And we're wanting to determine a lower tail region of rejection. So this means our HO is going to be greater than or equal to, and our H1 is going to be less than. So the first thing we need to do is determine our critical value of t with 20 degrees of freedom and a 0.01 level of significance. So again, we take a look at our t-table, and because it's a one tail, we use just the upper tail area. So at 0.01 and 20 degrees of freedom, we have a 2.5280 critical value of t. So with a critical value of 2.5280, you want to take special note. So anytime you're calculating a lower region of rejection, you make your critical value negative. Because negative 1.15 is greater than negative 2.2528, you do not reject HO at a 0.01 level of significance because it falls within the region of non-rejection. So now let's take a look at a problem using hypothesis testing with a one-way test. So here we have a patient waiting problem. Now, one acceptable standard of practice is that waiting times for a patient to be seen by the first healthcare provider should be less than 30 minutes. Now, a study was conducted to assess patient waiting times at a primary healthcare clinic. Now, the data collected was from a sample of 860 patients. Now, in this sample, the mean wait time was 24.05 minutes, and it had a standard deviation of 16.5 minutes. Now, let's test the null hypothesis at a 0.01 level of significance to see if there is evidence that the population mean wait time is less than 30 minutes. So the first thing we want to do is we want to identify all of our variables. We have our x bar of 24.05, our mu of 30, our standard deviation of 16.5, our sample size of 860, our degrees of freedom of 859, and our level of significance of 0.01. So the first thing we want to set up is our alternative hypothesis. So because we're wanting to determine if there's evidence that the mean population wait time is less than 30 minutes, that is going to be our H1. So our null hypothesis is going to be the mu is greater than or equal to 30 minutes. So we know we're doing a one-tailed test because we're looking at less than and greater than. So in a one-tailed test, the alternative hypothesis always points towards the region of rejection. So because it's pointing to the left, we know that we're going to be in a lower tail region of rejection. So since we have a lower tailed region of rejection, we also know that our critical value of t is going to be negative. So for our critical value of t, we look at the degrees of freedom on our t-table. Now we have 859 degrees of freedom, and the t-table doesn't go up that high, so you would just go to the closest, which would be infinite degrees of freedom. And you look at 0.01, which gives you 2.3263. So the next thing we're going to do is calculate our t-stat. So we're going to take our x bar minus mu divided by sigma over the square root of n. So our t-stat is going to equal 24.05 minus 30 divided by 16.5 over the square root of 860, which gives us negative 10.575. So negative 10.575 is less than negative 2.3263. So because it is less than, we reject HO at a level of significance of 0.01. So since we rejected HO, this is saying that the probability of us actually getting a sample mean of 24.05 or less, if the population mean is actually 30, is practically zero. So if you ran this through Excel or an online calculator to calculate out your p-value, your p would be 0.0000, which is the probability that you would actually have a mean of 30 given a sample size of 24.05 in a sample of 860. So there is an example of using hypothesis testing for a one-tailed test.